Bhavani Shankar, sir.
Hello.
Yes, sir. You are audible.
Yeah.
Sir, shall we go ahead, sir?
Yeah, please. Let's
Right.
continue.
Thank you. Uh, Let me introduce the today's day two, session two speaker. Mr. Bhavani Shankar is currently heading IoT vertical in R&D division in Effatronics Systems Private Limited. He is instrumental in its growth and positioning Effatronics as one of the India's smart solution companies. Backed by rich R&D, Effatronics is now a leading provider of smart solution for railway signaling, smart cities, smart building, and industrial domain. Mr. Shankar is the design architect to many IoT solutions innovated for different domains for the last 20 years. His area of expertise is building intelligence, edge devices, and sensing systems, data analytics, IoT platforms, and design thinking. Mr. Shankar closely works with academic institutions in various capacities for improvement of curriculum and teaching learning process. He is a part of BOS in various universities and colleges. He is a very active learner and keeps on upgrading with futuristic technologies and world best practice to the global exposure. So thank you so much, sir. Please let us go ahead for your session.
Yeah. Thank you. I hope my screen is being shared and visible to all.
Yes, sir. It's visible and audible.
Yeah. Thank you for confirming. So you please do the timekeeping and remind me uh, about the progress. The technologies we keep on showcasing or whatever solutions we have been doing with a lot of enthusiasm. Okay, coming to the topic I was given as a part of the FDP program, emerging technologies and AI in the context of climate change. So before actually going into the key areas, some of the solutions which might be of you know area of you interest for the academicians to carry out the research and also come up with innovative solutions around the sustainable uh, goals. One challenge globally we are seeing is that there is a tremendous impact because of climate change, and every year, all the nations come together. They arrive at plans and they announce a lot of at a country level, a lot of targets and you know, policies, action plans like that. But in reality, there is a lot of inaction. And according to one of the Deloitte research uh, paper published this year, it could account to almost $178 trillion uh, of a world economy, which could be impacted because of climate change by 2070, which is very huge and enormous. If you look at the economic disparity between developing nations and poor nations, it's a quite drastic impact. On the other side, COVID has disrupted entire supply chain, and also uh, the shock waves were observed in all the industries. But the impact will diminish over time because it may take time, but will certain sectors and domains have returned to the pre-COVID levels. Maybe there is a certain because of digital interventions, a lot of processes have been changed in another area. But climate change, on the other hand, is not temporary impact. It could be a permanent impact. That is what We are looking at only possibility for us, right now. We can mitigate and try to stop it, but we cannot look at alternative altogether. What could be the challenges? I- I'm looking at three important aspects. It will impact everyone, that we agree. Other hand, the consequence of it, we are seeing a rise of sea levels, particularly in low-lying places, and also having a ripple effect on the potable drinking water. Right now, amount of fresh water availability and also the amount of water which is safe enough to drink is having a huge crisis. What will the consequence of this will have a ripple effect which will drive majority of population to migrate to the safer areas in order to sustain. What will the impact of it? It will increase competition to hold the natural resources and use them in those areas. Second, to restrict that, governments will come up with new regulation banning the use of traditional polluting engines and also limiting the access to the natural resources and further utilization. That is going to be a cascading impact of climate change on individuals and also as a planet as a whole. Uh, Lately, there are a lot of artificial intelligence hype and also a lot of technological innovations around AI. Many organizations, many countries came up with different kinds of models to mitigate the climate risk or the impact. Six, well documented and very much hyped solutions I will just glance through, then we'll discuss on the what we can do at a technological level and what emerging technologies are coming and what are the areas we need to carry out the research and way forward. The first one which caught my attention was the melting of poles, both Arctic and Antarctic. Anything which requires manually analyze and understand is a time consuming and lengthy activity. It is challenging to him, particularly identifying how icebergs, you know, are getting melted or how uh, cloud coverage is, how sea ice is. This is a very daunting task. Now, in this aspect, AI is a great tool, and the models have been trying to measure changes in these icebergs, more than almost 10,000 times faster than a human could do, which is astonishing speed. What is the impact of it? So the technology, the models which are able to predict how the changes are happening will essentially help scientists understand how much uh, the melted water will be released into the ocean, a regular process, which accelerates the climate change in turn. And in particularly in the UK, University of Leeds, uh, the research team came up with their own AI model, which can not only map large Antarctic icebergs through satellite imaging, but it can also compute and analyze in fraction of a second. That is almost one by something around 10 microseconds or so, which is you can say extraordinary feat, whereas humans can't do that. And because it is so accelerated impact, we need AI to understand the change. The second area which extensively AI have been now being used is the deforestation. How to map the deforestation? One side you have satellite sensing or imagery, other side you have domain knowledge, ecology expertise. which we have to use to map the impact of deforestation on the climate crisis. Both we need to correlate. There is a startup in Edinburgh, Scotland, named Space Intelligence. You can look into that. It came up with a AI model, which is right now, mapping almost 30 countries, uh, ranging to almost 1 million hectares of forest land using satellite imagery, and they're able to, how, you know, estimate at a very granular level how much deforestation is happening. So it is measuring remotely metrics, deforestation rate. For example, they were able to come up with a very threatening statistics how deforestation rates have been accelerated in the last decade, and what is the how much carbon is stored in a forest, what is the net impact on the CO2 levels. Everything has been statistically derived. This is a great use case. A lot of technologies are going into this to not only map the deforestation but also at ground level understand the changes to the planet. The third thing, which particularly Central African countries uh, having a huge impact, because according to UN, there is Sudan, Chad, Burundi, these kind of countries are very, very vulnerable. As per estimates, entire planet itself form almost 400 crore people are in the unsafe areas, which is going to be hugely impacted by climate change. But these Central African and Sub-Saharan countries have a huge challenge right now. So, International Climate Initiative came up with a, solution which will not only help the understanding the climate change in terms of weather pattern changes, but it also able to correlate with the uh, uh, you can say in terms of geolocation. They're able to communicate and convey to the local communities and also authorities to how to plan to the climate change and mitigate its impact. The outcomes are looking at clean energy, implementing waste management systems, and also encouraging reforestation at strategic locations, which is extraordinary UN interventions in these sub-Saharan countries. Another interesting area is the recycling of waste. Waste we have different. Let's talk on the ground. Let's look at ocean at a later stage. Making waste management efficient is the one of the primary interventions to tackle climate change, and AI could help there because waste itself is the biggest contributor of greenhouse emissions, almost accounting to 15 to 18% of global emissions. And we are looking at a lot of startups, named Grey Parrot, which is based out of London, and also another startup from California. They have developed an AI system that analyzes waste processing and recycling facilities in their respective countries to recover and recycle most of the waste material. So far, the Grey Parrot in London has tracked more than 32 billion waste items across, 60 to 80 categories in year 2022 itself. It's recovering that instead of recycling that instead of sending into landfill, creating another waste island. They're able to address that problem. Similarly, ocean is a bigger challenge, particularly Nordic countries, in Europe. They have this lot of challenge because plastic, waste that accumulates in the ocean. That is a challenge because the tracking where the plastic, because they like a humongous islands, they float on the ocean. So Netherlands has extensively done this ocean cleanup program. They used a lot of not only digital technologies but also AI in particular to clear the plastic pollution in the ocean. What they do is they detect objects and they create a detailed maps of ocean litter across, clearly geotagging where that is. Then through vessels they collect the ocean waste, they gather that, remove from the ocean, and again try to recycle it. Earlier, they used to do trawlers and also some technologies used aeroplanes, but this is at a much larger scale and more efficient way. So they have done this. This is another great area because lot of waste is getting poured into the oceans. We need cleaning up of oceans as well, because at the end of the day that is also going to impact, because plastic pollution itself is the greatest contributor to climate change and harming the nature. Another is predicting the climate disaster. We have solutions and technologies which detect and understand the volcanic eruptions. Now, in Latin America, the companies like Cipremo and all, they have been using extensively AI and lot of IoT technologies, and both at ground level also using this remote sensing data to predict not only when but also where climate disasters will occur and what is the kind of climatic disaster that would be. It could be volcanic eruption, it could be wildfire, it could be floods, it could be hurricanes. They're able to clearly categorize, understand, geolocate where it's going to happen. The whole idea is to prepare the governments, authorities, or society for the climate change and also growing challenges that come with it. Now, they not only stop there, they're able to integrate these systems with the insurance, energy, logistics, sport, every other allied industries and domains. They were able to seamlessly integrate the data exchange. So the approach became more holistic. The analysis of disaster conditions became more holistic, and factoring the data from the energy, environment, like air quality, everything, we're able to come up with a more holistic decision support system for the governments, whether to delay or suspend events, whether to carry out evacuations, everything. These are the already existing solutions that have been extensively been deployed, explored, and put in place. Recently, uh, November only, second week of November or third week of November, I was in Kerala, Kochi. I was attending Gartner's symposium and IT Expo. Two things that caught my attention, which are very relevant to the subject we are discussing today. One, the predictions, one of the seven important predictions for 2025 or beyond is one is water scarcity. In India, we have only 4% of fresh water out of total global requirement, whereas our population is touching around 18% of human population, but we have only 4% of drinking fresh water. Unfortunately, the technologies like AI, the computing infrastructure, our devices, everything, our machines will drink water too, apart from human and animal. Why? Because AI itself, one classical example that was thrown to us was we all use ChatGPT, a generative AI. We all prompt, right? Let's say you want to understand what is climate change. You're asking ChatGPT. That simple question in the prompt. That itself consumes around zero point 0.5 watt hours of energy. One single prompt uses that much energy. Imagine to run the AI at scale, how many billion cubic meters of water is required. That is the statistics. By 2027, we are looking at almost up to 6.5 billion cubic meters of water diverted to machines instead of humans and animals. Not only that, because water also essentially we require, we require for generation of electricity, we require for computation powers, we require for cooling the gigantic compute infrastructure. Apart from that, we all consume energy in variety of ways. We are running out of water in all those combinations, and it is going to impact, and water reliance is going to be a big challenge. Now we are looking at wars done because of cultural and geopolitical tensions. Future we'll be fighting wars to get hold of water. And technologies, we have to move from liquid cooling to other forms. Our computation paradigms have to be shifted to more energy efficient computing. It is going to have a bigger implications. We, all of us, whether you are an academic institution, whether you are in industry, you have to perform your own water risk assessment now. What is your future water requirement? What is your present sources of water? What is going to be your future demand? And do the risk assessment now and look at alternative, reduce wherever, bring in technological intervention which are much more energy efficient, invest in the circular technologies, and which creates water loop. That is the only way. The second thing, which also is a adjacent disruption, which is the energy power play. Where will the power come from? One side we are looking at AI, which is scaling in astronomical ballistic way. Other side, we are seeing a lot of EV, push to EV. Third aspect, we are looking at a fully connected automation in industry. We are looking at automation at home. We are having a climate change impact. We are looking at population surge and pressure. Now, no longer a standard production, which can keep up to these demands. We have to look at other alternative ways. We need to self-generate. Kochi is a great example. The airport in Kochi, which itself generates its own requirement. We also need to plan for microgrids. We also need to have some sort of sharing consortium where power or energy could be shared by all the industries or communities in the cluster. It is going to have a huge impact. Once this shift happens, traditional power generation will have a disruption. Grid infrastructures will get completely changed. Power sharing methodologies, the policies, the frameworks will no longer same. Consumers and energy generators or leaders, they will see a bigger impact. So we will see more and more renewable energy per se. So these two I thought of sharing with you, which I found very fascinating where we are moving. Apart from it, one interesting slide where Gartner also publishes hype cycle. It looks at technologies in a hype cycle. A hype cycle will have a 5 stages. Any technology will have a trigger, innovation trigger. It goes through hype, where everybody hypes, like AI is now in hype. It is having a peak of inflated expectations from everybody, but slowly we will see no first generation of products will fail and we don't see their expected outcomes. Then it goes through the disillusionment, then slightly the second generation, third generation tech implementations will give us the abundant learning, which gives us enlightenment, and slowly we move to the mainstream, where the technology becomes mainstream. If we look at environment sustainability, the icons you see, the plain circle is less than 2 years. The blue light blue circle is 2 to 5 years. The dark blue is 5 to 10. The triangle indicates it more than 10 years. And if there is an into mark, it is obsolete, because before it actually become mainstream, the technology became obsolete because something other disrupted it. But if you see, I want you to focus on three. Let me take my highlighter. 1 second. Whatever I have spoken, the climate change adaptation, we are looking at 10 years. But interesting is, industry will also go into net zero factory. That means it will generate its own energy, it won't consume. So this is also we're looking at long term. Another one is an environmental sustainability of software as well, that has a long term change. But interesting is the blue things. One, you can see IoT for sustainability. IoT become a foundational technology for understanding the change, whether it is water supply, whether it is environment, whether it is energy. It all starts with monitoring. So that became mainstream. Then another interesting is the water management analytics, that is also becoming going towards disillusionment, but it will become mainstream in less than 3 years.
ಸರಿಯಾಗಿ ಏನು ಇಂಡಿಪೆಂಡೆಂಟ್ ಬೇಸಿಸ್ ಫೋನ್ ಮಾಡ್ತಿರ್ತೀನಿ.
And apart from it, you can see the hype of AI sustainability. It is going through hype. Whatever earlier use cases I said, it is there, but it will take another 2 to 4 years to become mainstream. So it indicates, the blue indicates that we have to immediately start working on those areas, those emerging techs, those areas. The dark blue indicates that we need to plan for it. So anyone who is trying to do research, pick the options of light blue and dark blue. Those are the areas we need to fully focus on right now. So I came up with, I don't want to showcase other people's work. So the remaining part, whatever IoT for sustainability we have done, uh, I would like to showcase to you all. So one area where an interesting thing is the water management. Like I said, 4% of fresh water availability and drinking water access is also becoming more and more challenging, because the water is a pristine resource. Lack of availability of water source, and also lot of challenges in the distribute or delivering the water to the household. If I look at applied design thinking, we at Ftronics identified the following challenges, which we converted them as the objectives to fulfill. The first one, even in our cities and towns where we are living, we are not sure the adequate quantity of water will be given to each citizen. One. Two, whether the water will be provided in timely manner. If they say 6 a.m., whether it is being delivered at 6 a.m. or not. The other aspect is the equitable distribution in the society, because a lot of people uses pumps directly attached to the municipal tap connection, forcibly sucking the water into their households. The pressure imbalances in the pipeline creates unequitable distribution, because the last mile households don't get enough water, whereas the people who are at a very front end of the downstream network take all the water as required, as needed. The other aspect is the potable capability of the water or quality of water. We are not sure. Lot of time there is a lot of leakages that seep into the pipeline because of sucking of forcible sucking of water. So all the drainage or wastewater also enters into the drinking pipeline. We are not sure whether the water is potable to drink or not. The fourth is almost all towns and cities in India have a unaccounted for water of more than 40%. That means 40% of water municipal authorities don't know where it is going. Whereas WHO, benchmark is 10%, whereas our unaccountancy is almost more than 40% in almost all the cases we have seen. The fifth aspect is when they use the energy consuming pumps and all do, in the entire network, the cost of operations is quite high. In they waste lot of energy to discharge the required amount of water. So these are the challenges which we converted into objectives, and we created a challenge what to monitor to address those challenge and what kind of controls are required. We look at it entirely upstream and downstream. So from source, you need to pick the water, whether it is river, canal, lake, pond, or a reservoir. Now, according to season, like rainy season or this thing, there is a variation of the water quantity and also the quality. Immediately after rainy season, you have abundant water. But once you move towards the summer, you will have very least amount of water which is available, which you need to uh, ration it. Now, this seasonal variation requires dynamic handling of entire management, also kind of filtration levels that need to be done in the water treatment plants. So to do that, to address those challenges, we need to not only measure the water quality attributes like pH, turbidity, and all, but also understand the quantity and quantum of water, like how much flow, how much level, what is at pressure, at which pumps are pumping the water, what is the energy consumed, what is the discharge, what is the efficiency. We need to monitor all those. And pumps and all should be automated. Valves should be automated, but this all requires a lot of fail-safe logics to be implemented. Similarly, at treatment plants, based on the water quality, their filtration activities varies. So again, apart from the same quality and other parameters, additionally they need to understand the chlorination level, because at the end of the day they inject chlorine gas into the water so as to kill the pathogens, and they ensure that certain level of ppm of chlorine is available in the water before they actually discharge. So not only opening of valves and pump, controlling the pumps, but there also automation of adequate quantity of chlorine dosing. Similarly, at a locality level, either you have a overhead tank, which we call elevated level service reservoir (ELSR), or ground level service reservoir, which is a sump. Now, at here we need to understand timely distribution, whether it is filling timely, whether it is timely discharged, adequate quantity is given, what is the demand and all, what is the quality, again all those things required. Similarly, at a metering area, district metering area, finally street and household activities are common. Now what to do with this? We need to ensure schedule adherence is more than near to 100%. Ensure 135 liters as per WHO is being given to the citizens. Bring down the unaccounted for water to less than 10%. Ensure the quality of water as per UN regulations. So if this is the solution what we proposed and implemented. This is a city. I took a simple clip art view of it. At a sorry, at the pump house where you're getting water from the source. we are putting these 7 instrumentation interventions, either physical sensing or physical control. Similarly, at treatment plant, we are monitoring the water quality and also timeliness aspects, as well as the pressure and how much is discharged, and also the valve control. Similarly, at a locality level, we measure the inflow, outflow, water level in the tank, and also chlorine level. At a metering area, flow and pressure, street also flow, pressure, and also valve controls, because if there is a leakage, we have to isolate that path. At a household, we put a meter to account how much water is being consumed, tank level sensing, and also valves and actuations. These are the technological interventions we bring in. Now the challenge is at a analytics and also machine learning, which we use to understand the consumption pattern and demand requirements, based on that plan for the future. So typically, this is how all these are connected over internet, through IoT devices and sensors. Entire data is coming to the central control room. So at a stack level, at a physical layer, we have sensors and actuators. At edge level, we have IoT devices. At a gateway, a software gateway, then data ingestion and device management processing. We have mobile apps for the people to control and act upon. Analytics to understand the patterns, and real-time dashboards, for various kinds of users. These are the things. This is the reference stack architecture. Example of these are the different sensors, devices we install in different locations, bring the data. And so one interesting experiment we did in the city of 2 million population, where we have done this implementation without telling citizens. For 1 month, we have given, you know 10% of the city, 1/10 of the city, 24/7, without informing them. The final conclusions from our experiment is citizens, or you can say households, have consumed 20 to 25% extra from their normal consumption when we give it in a scheduled manner, like morning and evening. And underline these percentage numbers. When it is unaccounted for water is more than 40%, which is citizens or municipalities doesn't know where water is going. If cities give 24/7, people are not using more than 1/4 of what they are getting now additionally. That means if you can save that 40%, bring down that 40% to 10%, this is, I'm not saying it is a correlation, but it is a one observation. If we can bring down that net unaccountance or wastage from 40% to less than 10%, that 30% saving is enough to give 24% water. That's what I mean. Without actually investing and setting up new pipelines, new tanks, new treatment plants. This is reality. So we use variety of sensors, a lot of, even it's not like we buy certain sensor and implement. No, lot of algorithms we need to build on top of it to reliably capture the data. And also the placement of sensors also plays important role, and finally using the data into some meaningful action. The core is the contextual algorithms which we built on the IoT platform. Lot of sensors: pH, conductivity, turbidity, chlorine, pressure, valve actuations, energy management, household meters. We have done 5 projects. Guntur also commissioned now. Another 10 projects we are doing right now. That's a look at it. Vijayawada city we done in 10 years back. Karbon we done it 5 years back. Solapur we done it 3 years back. Hyderabad, Guntur this year, and next year we are doing 10 locations or 10 cities. Look at the growth. It shows that climate change has a very, very adverse impact on the cities and towns, and which requires extensive this IoT interventions and modeling. Let me show certain dashboards. I hope yes. Please bear with me when I navigate through my dashboards. It takes some time. Yes. Like this, the data we are able to analyze and even identify anomaly in the consumption patterns, because when there is a per capita, that means per person, how much liters are being consumed. If it is going towards red, it is a challenge for everyone. Okay. Meanwhile, when it's loading, yeah, sorry for that. So one is providing the mimic, and second is looking at trends. The third aspect is looking at unaccounted for water trend, how whether it is reducing or not. And the extraordinary feat city of Vijayawada has able to achieve is they brought down the unaccountability in water from 40% to less than 10% in a year, which is no small feat, Um, that involve a lot of challenges, you know, fighting with public, fighting with politicians. The engineers were able to do because the technology is in front of them. It is empowering them with their decisions, what to do and where to do. Sorry, my internet seems to be very. Yes. So this kind of lot of dashboards we built, something around 40 different kinds of analytics and dashboards, and also ML model which will identify which area is having a more demand. So whether it is mimic, whether it is UFW, unaccounted for water. If you could see here, two areas they're able to bring down to almost, one is near 10, another is almost less than 2%. One is having a challenge because for certain railway station they are consuming without accounting, so we can't do anything there except they have to bring in or either charge them for money because they are consuming it without paying anything. So this lot of you know chlorine level, whether it is in required ppm, turbidity, the green indicates these are under control. So these are one use case which I thought of sharing. Another area which we worked extensively and done huge algorithm building is energy management. We can't save energy unless we measure, understand, and eliminate them. Okay. typically what happens, any kind of monitoring system, we collect data. Here in this case, energy data. Then we organize them. That means we organize in terms of how and in what way consumption is happening. Then convert that information into meaningful, actions or insight where people can implement energy conservation measures. So what we did was, whether you use existing meters, fine. Whether you want to deploy new kind of sensors, fine. All multiple parameters apart, not only energy, but we also capture temperature and also air quality data, and also if it is industry data, bring into real-time visibility. And we are able to create a baseline and also what we call prediction algorithm, which will predict tomorrow's consumption pattern based on the historical seasonality. And if it is deviating from the predicted or expected consumption, it will immediately alert through push notification and SMS and also through WhatsApp. So we built all the complete end-to-end uh, IoT platform for that. You can drive to anything. So whether you can use already existing devices or you can use electronics own loggers. The differentiation what we bought was, if you go by third-party smart meters which are available in market, is morely like single phase meter, three-phase meter. But what we came up with is multi-channel single phase. For example, in industry there is a distribution panel. You have to capture various loads. You cannot put 5 different meters there. Instead of 5 meters, you can have a single device. It reduces the instrumentation requirement or hardware cost, but it also, I know, on the capturing part, granularly captures sub in the millisecond granularity, which will enable the prediction algorithm to forecast and find anomalies. Whereas the traditional meters will give you once per second or like that, which is not enough for the AI or any model to quickly intervene. Here, let me again switch to the dashboards. Let me open on the energy front. In the building energy. So see here, in the facility, in main incoming, how many milliwatt hours are coming? So this facility has 3 sources. One is the grid supply from the electricity department. Then it has its own diesel generator, and it's also having a solar plant which is generating almost 352 kilowatt hour. So if you look at it, total generation is 2.79, and 2.79, how it is, the trend is daily how it is going on, and consumption trends also we verified how much is being consumed actually. So with this data, one first intervention the people brought in was all lighting infrastructure. That means your LED lighting in all entire campus or entire facility, lighting can run on DC power supply. So instead of giving the solar power to the electricity board, what they did was consume it locally for DC appliances like lighting, all the computers, laptops, everything is powered through solar power. So they're not only able to avoid or eliminate those multiple conversions, DC to AC, AC to DC, that 10 to 15% energy wastage is eliminated. And grid net metering is another challenge. Whenever there is something, the phases, it should be balanced, then only the power will be injected. Other thing is solar, the price for governments are paying is too low, whereas your electricity board unit is quite high. So the disparity, so if you able to consume it internally, it saves a lot of energy thing. So one is that. Another is We also see any industry will have a maximum demand. That means contractual demand would be there. So typically, what happens if this industry, for example, is having a demand of let's say 285 kVA. That's the maximum demand. If the demand consumption is going beyond that, there will be heavy penalty for the industries. If it is less than 80% also, you have to pay for that because they have put up the complete infrastructure for the demand you are asking. Now, what we did was the algorithm will look at these consumption patterns and your contract, and it will suggest, the model will suggest what is the ideal maximum demand for this facility, and it will help us in renegotiate our contract with the electricity board. One. Two, it will look at the energy consumption trend. The green, if you see, is the predicted one. The white one is actually going. The model with more and more data, with more and more seasonality, it is the green band you see will become much more narrow. You know, so the predicted model will say if it is beyond the prediction for let's say 10 minutes, it will intimate through notification there is a challenge. So we have done a lot of interventions on the energy. Uh, One is air conditioning is a bigger consumption. We look at air conditioning patterns, how outdoor units, indoor units. We have done extensive experiments on it. What if we put a green mat over the outdoor units? So the net temperature, ambient temperature reduces. That has a less load, on the HVAC system. All the internal, what we call glasses, where the radiation heat islands are forming within the indoor, that we have identified and trapped out. The third intervention we brought in was uh, scheduling all the appliances to switch off, which are not in the mandatory mode or critical mode. All of them will be switched off at 8 p.m. Whenever there is a certain loads are operating in non-operating hours, it immediately informs the our chief electrician and all the staff. So a lot of we brought in algorithms to bring down the net energy thing. Apart from it, the solar is a bigger. So what we put was the solar is there. So we also monitor the how generation is happening, cumulatively and at string level. Look at if there is any problematic, it will identify which string is having problematic, and it will also give in terms of yield factor. If you see here, rooftop is giving 4.7 times the capacity, whereas east and west elevation, when they put it vertically, it is giving hardly around 1%. Because now it is you look at season, you look at month wise. For example, let's look at June. You can see the yield is good. July, August, September, October, like that month wise you can see. So we, not only that, another thing is how can we correlate really our systems are efficient to convert the solar energy into electrical energy. So we put environmental weather station and started correlating the data with the generation, like the solar radiation. What is the solar radiation versus generation? So that correlation gave us, we correlate with the yield factor. If you see here, it is following the trend. If there is an anomaly, that particular solar, panels or strings having a problem. Otherwise, you are losing out the energy. So the environmental impact, real energy, how much is efficiently translated, everything we can capture. And the models will help us to identify the anomalies also. So this is another one of the use case which very much important. Another interesting thing which we did, you all people can also experiment in your own areas where you're working. Air quality. It could be a huge weather station, full-fledged weather station. It could be agricultural, or it could also be an interesting use case of median irrigation. Today, we have deployed almost 50 such stations across India. In highways, one of the challenge present government is facing is the median. In median, they want the plantation to grow. What is the ultimate aim is to eliminate the light pollution or light impact on the road commuter. So opposite light should not impact the uh, uh, fellow who is driving, because it falls into it may lead to accident. That is one. Obstruct the light pollution or interference. The second is when the plantation is also there, it will help in reducing the vehicular pollution to large extent, but they require irrigation. Traditional one, people used to put a tanker, one water tanker will go and they will occupy the entire lane, put a work in progress cones, and slowly they put water in the median. But the challenge is lot of manual effort, lot of water gets wasted, it drips out. Second, it is not timely because of occupancy in the lane. Traffic gets congestion because it is one lane is not available for use. Because of it, a lot of wastage of fuel from all the vehicles. Apart from it, tankers and all their usage, and also it may lead to accidents. Now, second stage, lot of places there is a drip irrigation. You might be aware of it. It reduced the effort, it reduced the wastage, but it is not fully energy efficient. What we came up with an idea is a smart drip irrigation, make it smart with technology. The idea is to have a weather station capturing a lot of parameters and also identifying the soil conditions in the median, like moisture level, temperature, and whatnot. And this works as a evapotranspiration station, wherein the algorithm identifies the more precise time in which water irrigation can be done, so that less amount of water is evaporated, so that entire water is used for irrigation without actually wasting it. Interesting algorithm. This is a great research area where people can also do work, and you make it automated. So what it will do, it is for scheduling that we know. It requires understanding air temperature, relative humidity, CO2 level, wind speed, direction, solar radiation. If there is a rainfall, there is no point in irrigating. So it understands with rainfall sensor what is coming, pressure, air pressure, soil moisture, what is the visibility level. It all captures that sense to the central place where the algorithm every minute captures this data, calculates the optimum irrigation schedule that is as a form of a command go to the field IoT device, which in turn will control the pumps and all those things. And again, it captures the field data and sends to the central application. It is a closed loop system. If there is a rainfall, it will stop irrigating because it knows. If the forecast indicates there is a possibility of rainfall, it still won't irrigate. So it reduces conserves the water, it ensures the entire water is being used without being evaporated or wasted. Two, it won't stop any traffic because it's an automated system. It doesn't require any manual intervention. This is a classical case which we have worked and implemented in the southern India, particularly in the uh, southern coast of Andhra Pradesh, from Chilikaluripet to Chennai, just before Chennai. Another is a battery. I hope I'm almost end. Kindly bear with me a couple of minutes. A conventional method for battery monitoring is these are lead acid batteries which are highly pollutant. People go with multimeters and periodically monitor, voltages, currents, etc., which is not possible. Which is I say not a right way of doing it, because any one problematic cell in a battery bank will collapse the bank in no time. So what we came up with is a system, an IoT system, which in real time captures the temperature, all the battery parameters, electrical and physical, at a cellular cell level, at a bank level, bring to the central place like a human ECG, identify every 60 millisecond granularity, all these parameters, and isolate completely, electrical isolate it from the bank so that there is no safety concerns. Find out what is the net capacity available, understand the ripple current, tell the state of charge, look at internal resistance. This we have deployed in massively across India. So like a human ECG, it will identify a problematic cell when actually being discharged. Other solutions is lighting. Lighting is a great case study for all of you, because you might be, okay, there is LED light. What is there to bring in technology? Any kind of LED itself is energy efficient, good. But when you add IoT on top of it, it will become enhanced energy efficient. That's where a lot of interventions is required. Come up with automation, come up with different kind of lighting. Light in air is useless. When you use the entire light on the target, then it is wonderful, or you can say really energy efficient. So for that you need to have mechanical design, optic design, industrial design, all come into cross-disciplinary approach. Use the latest energy efficient technologies, use the energy efficient computing algorithms. Even a poor algorithm which consumes a lot of power, CPU power, is also a problematic to climate change. Even though you all think, okay, it's a small CPU or a small mobile, what is it? End of the day, you use more power because you draw voltages from the electricity board, right? You draw energy from there. So if you look at this example, you don't see any kind of light in air. Only the target is being not simple electrical system, but it also come with lot of algorithms. This is an interesting area. Right now in ITC, ITC does the tobacco. I mean, they also manufacture cigarettes and do the processing of tobacco. Tobacco based on the color, the gradient, that means the cost varies. That means that they have to precisely grade the color. To do that, what they are doing right now is in a certain color temperature. That means in a day, in a certain time only, within that 1 hour, they have to, human have to see the gradient and identify. Look at the inefficiency. Sun temperature, when it is at a certain Kelvin temperature of color chromacity, that means I'm talking about color temperature, like a sun also have a color shades, right? When it is in certain color rendering index of greater than 95, you can do the inspection. Based on that, people will buy the tobacco, and the cost also varies. So what is the technology intervention is, one, we made color rendering index greater than 95 with the light, because with mix and match of RGB, we are able to achieve that. Two, instead of human grading it, a precise illuminated target area powered with AI camera or neural network algorithms, we're able to grade it. Classical case of computer vision, but still it enhances the efficiency. Otherwise, they waste a lot of energy. Look at this another example. There are no dark spots. It is uniformly lit, and there is no wastage of light, only on the target. And this lot of dimming, sensor based, motion based, lot of interventions came. That all adds to energy conservations. Uh, you people also work on different areas now, particularly in the water disaster. One classical case is right now we are looking at urban floods. That means suddenly there is a lot of floods in the cities. That is, the frequency is increasing day by day. Someone has given the tilting and all. That's good. uh, because of depletion of underground water. Now, urban cities in India particularly have a open drains. Majority of them, they are open drainage system. The suddenly the amount of water we are seeing is cloud burst. The rate at which water is coming onto the ground is too high. Rate at which the drainage system is able to discharge or take it out into the river or other side has a different flow rate. So there is a mismatch. You need algorithms to model. You need different technologies to monitor the levels in the drainage system, the flow in the drainage system. Traditional sensors won't work. You need to build new kind of sensors. These are another area, a good research area, someone to do thesis and come up with a solution, not a paper, but with an actual working model. The another area is a lot of cities now deploy ground level air quality stations. That means rather than satellite remote sensing, they deploy at ground level in every traffic junction. Dehradun city has such 50 odd this thing. I know Kochi has few. I know Belgavi have few. So what you can do is, how can you tie up with these municipal corporations or smart cities limiteds, approach them, uh, give proposals how to use the data which are being already captured by these ground level stations and forecast the climate change. Tell the models what is in it for municipal corporation. By sub innovation, you can tell if you measure this air quality levels in different parts of the city. For example, residential areas have certain limitation amount of pollution that can be allowed. Commercial areas have certain level threshold. Industrial areas have certain threshold. If a residential area, if you find industrial level pollution, that helps municipalities to act upon it. And you can also, in over months and years, you can understand the CO2 level increase. When there is CO2 level increase, it is indicates there is a green coverage is getting reduced. In fact, when we looked at Dehradun city's data, one interesting finding what we observed was during the COVID period, that entire lockdown period of few months, lockdown period and also extended work from home situations and disruption to activities, within 6 months, we have seen instead of 410, 415, which is used to be outdoor CO2 level, we started seeing 380, 385. That is extraordinary because there is no vehicular pollution, there is no industrial pollution at a large scale. So it helps the models, the technologies which you deploy, helps in understand the climate changes and what are the different contributors. That is another research area you people can start working on. The third area which we have is on the waste. Okay, the Latin American, European countries are doing it at a different scale, but our challenges are different. Our road traffic conditions are different. So waste management, bring developing a solution to increase the, or you can say shorten the journey time in the cities. So you're going to your institution from home. Typically now it takes, let's say, 15 minutes on an average. how can you build a solution with technologies to reduce the journey time by 10%? Let's say instead of 15 minutes, make it 12 for everybody in the city. That requires a lot of algorithms and technology. But if you do that, imagine uh, uh, city of Kottayam with a million population or so, I don't know exactly. Let's say a few lakhs of people, out of which let's say 1 lakh people are every day traveling here and there. Collective vehicular population you can reduce because that time on road is less, which indicates proportionally less carbon emissions. So look at these areas, everything has a climatic impact. And these areas we are finding very, very minimal research. Everybody is looking at AI models, particularly in the computer vision only. No, a lot of things are happening, a lot of opportunities there in the other emerging tech. Be open to that. AI in computer vision is one area, but AI you can use it for different other activities as well. So that is from me. Thank you. I'm sorry I'm overshoot by 10 minutes. If you have any, I will share the presentation back to the coordinators. They will share with you. Uh, if you have any queries, you can just.
Yes, sir. Thank you. Dear participants, you can interact with the resource person, please.
Good afternoon, sir.
Good afternoon.
My name is Rajkumar Bhandari, research scholar in Bishwabharati, West Bengal. I
Okay.
have a question that I am currently working in smart irrigation system. So you showed that there is a optimality is getting using the various sensor using IoT.
Yes.
So how it is getting that? Can you tell me some idea about how the optimality is getting?
You're talking about irrigation?
Yes, 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 sir.
That to median irrigation or general agriculture you're talking?
General agriculture, sir.
General agriculture is different. For example, anyway, I have seen the agenda. One of the topic is the precision farming. Anyway, you will learn from another speaker. Typically, what happens is, for example, highly consuming crops like corn or sugarcane, which use gallons and gallons of liters per hectare. Typically, what happens is how much water is adequately required. Uh, Second, what is the biomass? What is the water logging in the area? What is the right way or right time for irrigation? This all requires intervention from technology. Precision farming uses variety of technologies. What one is ground level sensors where you put soil moistures to understand the moisture content in the soil. You have different kind of sensors to understand the nutrient content in the soil, biomass, and you have drones with the AI vision and all, understanding the pest type of pest, uh, and the forecasting systems understand the weather, what is going to happen. So all these technologies in total together, when you apply, the farming becomes or irrigation, or you can say cultivation becomes much more dynamic, much more efficient. That's what I mean. When you do that, particularly Latin America, using extensively on the corn, they're doing great job of precision farming. So they are able to reduce almost 10 to 15% in the net consumption of water. That is a huge impact. Imagine, I don't know West Bengal, what is the, whether it is paddy or sugarcane.
Sir,
So
it is mainly paddy.
yeah, then paddy also, what is the right amount? What if you say what is smart? End of the day, putting a sensor doesn't make it smart. Using that sensor, using the understanding the future, correlating both, contextualizing it, and deciding what to do. So IoT sensors and all give you that information what is happening. your contextual algorithm has to understand the context, extrapolate it to the future, and decide what to do. So that area still lot of activity to do in India. You can look at it, but
Okay, sir.
essential is understanding the soil conditions. That is
Yes, sir.
fundamental. Second is understanding the crop condition.
Okay, sir. Thank you, sir. And one more question. Uh, which platform you use for data visualizing? That one platform user?
Uh, I mean, we built our own platform for you. Two things you can try. One is Grafana, which is open source free tool. You can install in your laptop. No extra programming capability is required except you write some piece of query to fetch the data or organize the transformation. Second one is academic purpose. I don't know what is the cost, but there is another from Microsoft Power BI, which is also good. But Grafana is a real time where it doesn't require any kind of license or any kind of cooling period. That means Microsoft restricts that you cannot refresh the dashboard, let's say 48 times per day. If you are on enterprise edition, if you are on free edition, it is eight times per day. That means it's not real time. It is more like a postmortem. So Grafana is a good fit. You can start from there. You get
Oh,
almost hundreds of visualization techniques there.
okay, sir. Thank you, sir.
Yes. And I put in my email ID and phone number in the chat box. If you're not able to ask here, you can drop a mail also. I'll reply. Thank you.
Okay, sir. Thank you, sir.
Any other questions?
Yeah. Anybody want to interact with resource person, please?
If not, still I'm open to the digital conversation also. You can contact me. That is my WhatsApp number also. You can just drop me a message. I reply.
Sir, can I ask one question?
Yes,
Seema
Kim.
Shivasu
Please go ahead.
from Greater Noida. Yeah, as you talked about the waste management and water scarcity and all that. So, don't you think that we are polluting our water resources, water bodies, lots of garbage we are putting up, and then we are finding out solutions through technology. We are polluting our main water resource, rivers, and all that, and we wanted RO at our home.
Yeah,
So, I mean, is it we are going
yeah,
in a right path?
yeah. See, that is also what we call dichotomy. For example, we all use air conditioning systems in house. Why we are using it? Because our temperatures are quite high. We want comfort. We want to be in a comfort environment conditions. But if you use it, that is because there is a high temperature outside. But if you start using, everybody start using air conditioning system, our energy demand will go. To again compensate the demand, people have to burn more fossil fuels now. That means again more rise to the global greenhouse emissions and the temperature rise. It is a dichotomy. You're right. Other than other countries, compared to other countries, India has the unique challenge. Our sensitivity to understanding waste is very poor. For example, we don't segregate waste at household level. We mix everything.
Yes, sir. Yes. Hmm.
So it need to start at individual, then it need to be streamlined at a municipality level. Then we can look at other things. But what we are looking at is a bigger change. When we pollute our land is one consequence. When you pollute a ocean is a different consequence. Everything start. The dichotomy is there. Individually, we have to cover. We have to sensitize, but that without correcting its source we can't do anything, but ultimately we have to look at different kind of interventions at various levels, so that is needed. I agree with you in water.
Actually, so, like I've been living a zero waste lifestyle from last 7 years. I don't have dustbin at my home. We manage, well, I manage all my waste. But when I see people like how they are polluting this planet, like, it starts from them itself. Okay, but they
Yeah,
are not doing it as their
that
responsibility.
that
They are not
that's
that much
because
conscious.
that's Seema, that because you might have been sensitized, you might have been sensitized quite early, and you have that resources and privilege to do that. But it's not possible. That varies between people, that varies between our social conditions. There are a lot of challenges, but this is a never-ending task, and we have to sustainably do that. I agree.
When I read somewhere by 2050, there will be more fishes, there will be more plastic in oceans than fishes, isn't it? So,
Yeah, the little
threat to our human existence actually.
that, see, always having a positive fear is good. Whether plastic would be more than the fishes, I don't know, but autonomous drones would be more than human population by 2035.
Yeah,
That I'm
yeah.
100% sure. So Selva Prashant is asking something. In water quality monitoring, is there any inbuilt sensor available? What do you mean by inbuilt? You have various sensors. You can understand pH level. You can understand TDS, turbidity, chlorine level. You can understand conductivity or salinity level. You can understand dissolved oxygen level. You can understand uh, nitrate, ammonias. You have variety of sensors that are already available, and you can capture, but it's a bigger subject, not easy. Just connecting won't solve the problem. That is another use case I thought of. Aqua is another area where we have done a lot of work. I thought of sharing that as well, but I've restricted because time is limited. So those sensors are available. Sensorx, SCNSOREX. Look at that company. They have the variety of water quality sensors. It's US based, very good. You can buy locally in India. Integrated sensor, no, you don't get that. Like, it's not a integrated gas sensor where you can have 3 4 gases in one. No, not possible. It has to be independent. Maybe
Sir, another
but
question is
maybe
there.
you can collate if any additional questions are or any other feedback aspects, and you can send it through email. I'll try to answer as many as possible.
Sir, how are the security challenges of an IoT based system managed? One question is there in the chat box.
Chat box security, interesting. Typically, when we are looking at fully connected automation, when every system is connecting to every other system, right now people are working on the interoperability standards, because end of the day they have to make it fully system of systems approach. But security has, right now the emphasis is on security at every layer. For example, you are working on a sums board. I understand many of the academicians, you know, try use Raspberry Pis and Arduinos because it is easy to do experiments. But when you develop any kind of IoT hardware device, which is having lot of third-party packages, operating systems, and libraries, embedded into it, it is always a challenge to comply with security aspects. The modern ARM chips comes with inbuilt security features. One, the encryptions are already there. We can use that. Apart from that, now they're bringing separate hardware engines inside the chip itself to handle the security requirements. So I recommend, when you're building IoT devices, ensure you're building on what we call as bare metal ARM hardware. Bare metal means there is no operating system. You don't use any kind of third-party drivers. Everything, every piece of line you write. That is one. Second, as much as possible, try to avoid web technologies. Build your own stack. Have your own dedicated secure TCP socket. Try to exchange information in it. And storage has to be encrypted. In data in motion has to be encrypted. And payload has to be having integrity checks. Even you store in a database, it's to be stored as by encryption. Apart from it, when IoT is strictly personal technology, now inside, for example, you put a continuous glucose monitor sensor in your arm to measure the glucose level in your body. It is a personal IoT gadget. The data you're capturing, it goes into cloud. Who is using it? You are not sure. So it is up to the individual and the application to take care. As much as possible, work on bare metal, it will reduce the security vulnerabilities. Second, avoid web technologies that will further reduce the requirement. Third, all latest ARM semiconductor SoCs come with inbuilt security engines. You have to use them. And even when you're working with mobile applications or wherever you're using, as much as possible, always it has to be on the fly. It never to be within store in a database within device as well. It has to be on the fly.
Yes, sir.
Anything?
Almost all questions are we covered, sir.
Okay. And if anything is there, I'm sorry, it's almost 9 p.m.
Yes, sir.
Maybe we can hard stop here. But I have given my contact details. You can share. And also, Dr. Ravi, please share the feedback. I don't know how far.
Definitely, sir. Definitely. You can see in chat box, sir. By default, I will share you the feedback also. No problem.
That's it.
But anyhow, thank you, sir.
Thank you.
Thank you so much for accepting our request and came forward to deliver your expertise towards the IoT. And thank you so much, sir. You were given the lot of information and lot of challenges towards the IoT related aspects which are related to the energy sustainability.
Yeah.
But once again, thank you so much, sir.
Yeah.
Thank you, sir. Bye,
Thank
sir.
you. Thank you very much.
Have a great
All
day.
the best, and hope people learn from this FTP and start working on certain areas in their research.
Yes.
Yeah.
Thank you, sir.
Thank you.
Thank you so
Sir,
much.
thank you so much, sir.
Yeah, thank you.
Yeah, participants, as usual, schedule by tomorrow. As per the schedule, we will follow. Once again, it's a request from our side. Please join with your registered name. Thank you all. Have a great day.
Thank you, sir.
I think we can close the meeting, right? Stop recording.